What is a killer app? A killer app denotes a feature that is so compelling that it drives the adoption of a technology. So what will be the first killer app for enterprise AI? My bet is on Unified Natural Language Query because it is the future of business intelligence. In this video, you're going to learn what it is, how to find business opportunities for it, and how to create your own customer demo in minutes. Let's get into it. This is episode 3 in Prolego's AI strategy series. In episode 2, I explained why an automated document processing solution is the best opportunity for a quick win at most companies. Unified Natural Language Query, or Unified NLQ as I'll refer to it today, is a slightly more complex solution, but the business impact is significantly higher. So let's start by talking about the business problem that we're trying to solve. Every executive I've met is frustrated by their inability to get simple answers from their data. For example, a bank manager may want to know how many customers opened a checking account last month with a balance above $10,000 and who don't yet have a savings account. This seems like a straightforward question, and it is. But in practice, most companies struggle to provide their leaders with answers to these type of simple questions. Let's look at some examples to discuss why. Prolego created this simple demo of Unified NLQ using OpenAI's GPT-4 model. It is open source software, and I'll show you how to download and customize it for your own use in a moment. It is a very simple table representing the type of fields you would expect in a bank's customer relationship management system. The table's columns are on the right, and they contain information about customers and accounts, including a notes field that could have been entered by a bank employee. The user simply asks a question about the data using natural language. Let's start with the default question. Which customer has the most money? This takes about 30 seconds to run, so I'll jump ahead. The AI language model generated the SQL from the question, and we used it to query the database to get the result. Let's take a pause here and consider how amazing this is. Empowering users with the ability to do simple database queries has been the holy grail of business intelligence tools for years, and GPT-4 does it with ease. But as we will soon see, this is only the beginning of what's possible. We can also use the language model to provide context to the person asking the question. In this case, the question we asked was ambiguous. I asked, which customer has the most money? Well, what did I mean by money? Just liquid cash in checkings and savings accounts? Or should it include the less liquid Roth IRA column? Should we consider liabilities like mortgages? Well, it just isn't clear because my original question was so ambiguous, and a user who just gets an answer may interpret the results very differently. We can remove the ambiguity from the user by providing context with a large language model, using it to explain the query in natural language. In this case, the user can learn what asset classes were considered without needing to read the SQL code. The ability to create this type of context and explanation is one of the reasons why Unified NLQ is the future of business intelligence. You can use the reasoning power of the large language model to help the user understand and act on the results. You simply don't get this context from static dashboards and reports, but as valuable as this functionality is, it is only the beginning. I decided to push the demo a bit harder by getting it to parse the information in the unstructured notes fields. I started with a simple data discovery question. What type of information is available in notes? The model then read through the data and summarized it for me. This is real business intelligence, and I used it to begin a deeper exploratory conversation with the data. Based on the results, I asked it to return a set of customers who meet certain criteria. In this case, I asked for a list of account owners and the ages of their children. Again, the model not only gave me the results, but provided the answer with context, including why 2 account owners were excluded from my question. I then asked the model to analyze the customer's data and provide a list of the best potential candidates for a student loan based on their financial situation. Note that I included information from the last query result because this simple demo doesn't retain state between previous conversations. We will demonstrate how to overcome this constraint in future episodes of this series. Notice how the model brought reasoning power and knowledge about the world to the answer. It knows at what age children go to college and why someone would take out a student loan. It not only provided an answer, but provided explanations on how it was created. Again, this is incredibly powerful in the real world because users don't know what information their data contains or what they can do with it. We've all witnessed business intelligence teams and engineers spend months iterating through different types of discovery conversations with customers. Providing users with the ability to get into a dialogue with their data can provide significantly faster insight. To that point, Unified NLQ creates a goldmine for learning what customers want. By capturing and analyzing the questions customers are asking, a team can get real-time feedback on how to improve their products. I realize this is a trivially simple demo, but I learned a ton about the possibilities and constraints of Unified NLQ just by playing around with it, and I would encourage you to do the same. Let me show you how. The installation instructions are on the Nia Sophia README along with the open source license. Check out the links in the show notes for a link to this GitHub repo. If you have a few basic development skills, it won't be a problem to install it and customize it yourself. Just install the source code and add your open API key. You can then launch the script for episode 3. Now let me show you how easy it is to generate your own demonstration data for your customers. I asked ChatGPT to generate a CSV table for me, in this case for a life insurance use case. Here is the prompt. I then pasted the CSV file into the bank_customers CSV file in the code, saved, and restarted the application. And that's it. You can see now we have a customized data set for life insurance underwriting use cases, and we can start testing the model to see how well it performs. So that's a quick intro to Unified NLQ. I am convinced it will become the killer app for enterprise AI because even a simple deployment like the one I showed you today can create valuable insight for leaders. I learned a ton just playing around with it, but I'll stop here and talk about some of the limitations to help you set expectations. I am not suggesting that you can connect a large language model to your 100 million row data lake and begin magically having a conversation with it about your data. Obviously, this is a much harder problem. This demo is best thought of as a simple SQL generator combined with the reasoning power of a large language model. In practice, things get harder when you begin working on real problems. For example, querying across multiple tables and adding other additional data sources such as text documents, web searches, or APIs. And GPT-4 is still slow, so there are latency challenges in retaining state between questions and performing error checking to prevent hallucinations and improving results. Fortunately, Prolego has been digging into the research and working on these type of challenges that we expect our clients to have when they're trying to solve real business problems. And we're going to address them in upcoming episodes. If you don't want to miss out, be sure to sign up for our newsletter and I'll let you know when they are available. Let's wrap up with a discussion with Prolego's engineers about the code and what they learned from building it. Okay, well, welcome, Justin. We wanted to provide some background on the Unified NLQ demo. I guess then let me make sure I understand how this is built. So we get an LLM, we connect it to our data lake and our file system, turn it on, and we can just ask whatever question we want. Do I pretty much have it?
I wish that were true. In reality, it's a little bit more work, a little bit more connection is needed.
Okay. All right. So we don't have the holy grail of business intelligence here. But before we dive into the code itself, can you just walk through at a high conceptual level, kind of like what's happening in this application and how we're interacting with the LLM?
Absolutely. So in this case, we have a single table from a SQL database, and we want to use natural language and an LLM to ask questions about this database. So rather than writing SQL myself, I would like to use an LLM, and I'll ask a question to the LLM. I want the LLM to generate the appropriate SQL query, and then under the hood, I can run that. But then I also want the LLM to take the results and then summarize the answer, summarize the response back to me. So essentially, I'm using natural language to ask a question about a database and then I get a natural language response from the LLM.
Okay, excellent. Well, with that in mind, let's jump into the code and point out a couple of items for some of the people who are watching. So we're looking at the SQLite chat.py file that's within the code base of Nia Sophia. The location of this file is shared in the show notes below. Can you just kind of give a high level overview for the audience, let them know what's generally happening in this file?
There's really three main components. The first one is we need to construct the prompt for the LLM. This is how we present the context that the LLM will need to know about, like what's in the SQL table, what are the columns, what do the columns mean, things like that. And we need to present our question that we want answered. We also need to tell the LLM how it should respond, because in this case, we're not just having a conversation like you might have on ChatGPT, but we need structured response from the LLM, a SQL query. So that's actually a lot of the code here is creating the parameters for that interaction. How am I going to ask questions? How am I going to present context to the LLM? And then on the backside, how do I get the response from the LLM and interpret it meaningfully, meaning extract the SQL query? So a lot of the work is in the prompt construction and then deciphering the response from the LLM. It's just the call to the LLM, which is just a couple of lines because we're using OpenAI's API.
Okay, then, so are we retraining the model? Any kind of fine tuning of the GPT-4 model?
No, there's no retraining. There's no fine tuning. Really, it's just a lot of experimentation to figure out how to most effectively interact via prompting with to the LLM.
Okay. All right, well then let's jump into I guess the main workflow of the application here on line 152. Can you walk through with everybody kind of what's happening here?
Absolutely. So again, we want to interact with, in this case, a SQL database that's a single table. So in 155, we just set up the connection to the database. In 157, this is where the prompt engineering, the prompt construction starts. So it's getting the user agent prompt. And if you look at the inputs to that function, I'm telling it the schema, so what's in this table. I'm telling it the table name, and I'm giving it a question. And this function will take those pieces of information and construct a prompt, the text prompt that I can send to the LLM. So that prompt is going to contain these three things. It's going to say, here's what's in the table, here's the table name, and here's my question about the contents of this table. Once we have that prompt, then we can go down to line 160 and send it to OpenAI's API. We take that prompt message and send it over the wire and wait for a response. Then once we get the answer back from OpenAI in 169, start going through this process of checking the result. Well, hopefully the LLM sends us back a SQL query. And if that's the case, we need to extract it from the response. We need to actually run the SQL query against the database, get the response from that SQL query. And so this loop starting on 170 is going through that process because the LLM doesn't always get it right. It might give us a SQL query that doesn't use the right column name, or it might have some other error in it. And we can go back and forth a couple of times, though. In many cases, after one or two trials, the LLM will get the response correct and actually give us the SQL query that we're looking for.
Okay, so this is sort of workflow error handling, calling the database here, and I'm guessing this is necessary because when I'm talking with ChatGPT, it can give me all kinds of different answers, usually correct. But even if they're correct, they're in different formats. But in this, we have to have something precise to run SQL. Okay,
Yeah.
excellent. Okay, so then what happens sort of later on down into the workflow?
Yeah, so the last step, if everything's gone smoothly, we've constructed our prompt with all the necessary context, sent it to the LLM, we got a response. It has the appropriately formatted SQL query. We ran that. And this last step is just taking the response and summarizing it in natural language. So rather than giving us the table response, it's going to use English to describe what the actual outcome of that task or the output of that question was.
So it looks like a lot of this happens in one call to the API, so that you're capturing some of the. So this isn't multiple calls to ChatGPT to generate the response and the explanation in the context. Is that the case?
There will be at least two calls. The first call is where we ask the question, and
Okay.
then if we get the SQL query, that we can run that. And we could be done there, but we're running this last step, which is, okay, now we've asked the question, we've gotten the output from the SQL table, and now we want this last call to the LLM to simply summarize what's happened, give us an English sentence or two about the output or the outcome of our question.
Okay, I got it. So when I went through the demonstration, I really talked about the context that we provide in this demo for the user. And this is in this part of the code, I guess the second call to GPT-4 is where you could put that context in whatever would be most useful for your users or your particular customers. Excellent. Okay, so then why don't we just jump up to some of the, I guess is the more the meat of the work here, which is the prompt construction.
Yeah, that's really a lot of it. Because in this case, we can't just ask a question about the database, we need to describe it. And so that's what the function on 85 does. We give it a table name and then construct this message that we'll send to the LLM. So, hey, here's the name of the table you have access to, and here's the schema for that table. So the names of the columns, the data types contained in those columns. And with that information, we hope that GPT-4 or an LLM can know how to interact with that table because we've described it sufficiently. And this is not perhaps as obvious as it seems. We've gone through several trials or several rounds of experimentation, figuring out how to best present the context for the database. How do we describe the database so that the LLM knows how to generate appropriate SQL that will run against the table?
Got
So
it.
once we have that context around the data in place, we can continue adding to our prompts, which is what the function in line 94 does. And that says, now that you have the context, well, now we're going to ask a question. And so you see we have below is a question from the user. We fill in that question, and then we tell the LLM to generate a SQL query that pulls whatever data it needs in order to answer that question. And then the last line on 101 is just a one-liner, but it's actually an important one-liner because there we're telling the LLM how to respond. Because as we mentioned earlier, we don't want it to just talk back to us conversationally. We want it to provide a precisely formatted SQL statement that we can extract and give to the database connection. And so that one line, if you were to follow up on what EXP query template looks like, that's our JSON formatted template telling the LLM how exactly it should respond with that query. So yeah, here it is. We expect something in JSON that looks like JSON in the response. It should provide an explanation about what it's doing, and then that query in triple tick marks, which is how we want precisely the LLM to respond with that query.
I'm not a programmer, but I was able to kind of follow the rest of the file. Then you've got some UI in there and some other kind of basic workflows. But I mean, really, it seems like the meat and potato of this is like the error handling, and then just the details about how to engineer the prompts to get what you're looking out of the software. This is fascinating stuff. I guess maybe breaking out of the code here and just talking about concepts for a second. As I watch you guys working and talking about this, it really feels like a completely new way of thinking about programming. And instead of the 50 years of software engineering history where we interact with dumb functions based on brittle rules, now we're interacting with an intelligent brain to build powerful systems. So what's that like as a developer to work in that kind of environment?
It's honestly more like working with another person. I mean, imagine you hired a remote intern and you could only communicate via email. You need to create some constraints around communication. Say, look, this is how I'd like for you to send your messages to me, and this is how I'll ask or send you tasks. And so you kind of have to define the constraints around the conversation, and it's not always going to be correct. And so sometimes you might need to go back and forth. Well, that wasn't the information I was looking for. Try again, or write this communication differently. It's much more like learning how to communicate effectively with a colleague than it is writing a strict and precisely defined function like you would just in software development. There has to be a little bit more latitude for interpreting the results because it's a probabilistic model that we're interacting with.
Which is completely different than all other software development paradigms where you just have like, it's all about, strictness, structure, rules, no gray area. Now we're dealing with ambiguity and gray area. So it looks like just to do this, it's just a lot of like trial and error and testing and figuring out.
It really is. Experimentation is really important. Learning how does the model respond to different prompting techniques, going back and forth until one works, most of the time, and then writing code around that to catch exceptions because it won't work all the time.
Right.
But sort of create a safety net so we can catch a lot of the expected expectations, go back and forth a little bit and with the model and get reliable results.
And the models are, you create those safety nets with the models, right? It's almost like you got like another employee says, hey, listen to what that person says. And if it sounds crazy, let me know. Absolutely
exactly.
nuts. To help manage expectations from, maybe a product team that's going to start working on this. They want to manage expectations with their management. I can guarantee you that there are going to be some people out there, leaders are going to hear about this and say, this is amazing. Suddenly we'll be able to ask whatever I want on my data like ChatGPT and I'm going to get everything I want. So can you help arm those people with maybe what are some of the constraints of this simple approach here? Where are you going to run into the limitations of what it can do?
Two things come to mind. The first, what we've talked about today, we're interacting with a single table. In reality, databases normally contain multiple, perhaps many tables that are all interconnected, where you do joins between tables to extract certain information, link certain data. And so when you scale up the database to that kind of scenario, one of the challenges is telling the LLM how your relational schema operates. What are the connections? What are the joins that are possible? What are the fields and tables? How are they defined? And so that's it's almost like data engineering in the world of LLMs. We have to describe the data and the schema to the LLM so that it knows how it can use the database. So that's a non-trivial challenge. It's something we're currently experimenting with and developing. The second challenge is on the complexity of the task. A lot of the questions we'll ask of this one table, those questions can be answered with a single SQL query. What happens if you have a more complicated question that requires multiple steps? So it has to run one query on this table and then do a join and get another piece of the puzzle from this join table over here. And maybe you have 3, 4, 5 different pieces that have to come together to form the final solution. So that type of multi-step problem solving requires a slightly different approach. We need, in that case, something that you'll hear called an agent that's able to take one piece at a time, break it down, solve each piece, and then synthesize a response over those multiple components.
What else have you been working on and what can we expect to learn in future episodes?
A lot of our work recently has been looking at that multi-step problem-solving challenge. How do you get the agent to appropriately break down a complex task into pieces? How do you get the agent, the LLM, to use functional tools that you provided, like a SQL database connection in this case, but it could also be going to a document store. It could be going to an external API. And so learning how to effectively construct prompts, construct constraints so that this LLM agent knows how to break down complex problems piece by piece, use appropriate tools, and then construct a final response. That's been a lot of our attention for the last few weeks.
It is so exciting. And I think what I find so shocking is just, and I'm not the first person to say this because you'll hear this from startups everywhere, is how fast you guys can make progress. And when you, even a small team with these incredibly powerful tools, what you guys are able to do in hours and days is absolutely unbelievable. I have never seen anything like it in my career, how quickly you're able to just overcome very hard problems with these tools. I mean, these LLMs are unbelievable when you start programming with them.
Yeah, well, it's really exciting. And it's, like you said earlier, it's kind of a brand new paradigm. So I think we're all very excited and very motivated to jump in and solve some of these challenging but fun problems to work on.
Well, I don't know about you, but I can't wait to learn more and see what techniques Justin and the team are putting together to solve these types of problems. If you are excited about bringing this amazing capability to your business, don't hesitate to reach out to us. Just email my business partner, Russ, at russ@prolego.com, and we'll be happy to talk through your options.